All right, welcome back to college algebra. So hopefully we can knock out the rest of 2.4 here. Don't be afraid to ask me a question about this. I'd be happy to do more of these problems. I know they are, they're a little on the complicated side. So they're a little involved. So don't get discouraged with it because you will make minor mistakes, and you're just going to tell you that you're a terrible person. And you probably have to go back and redo. And if you have to go back and do it several times, then it's going to get very frustrating because you're going to have to do it more than once. So understand that there's a lot of parts to this, and if you screw up even one tiny little spot, it's going to knock the rest of the problem out for you. So these are these are terrible because they don't guide you like step by step to do it. So just want to give you a little bit of reassurance, like you're trying them, you are going to be getting better, and despite how awful some of these can be and how long some of these can be, that's the way of it. Okay, so we have a degree 3 polynomial, okay, with coefficients of zeros, or with integer coefficients rather, and our zeros are negative 7i. I mean, I mess these up too still, right? Because every time has to be perfect. And 5x, 9 over 5. All right. So they want the whole polynomial here. Okay, they do not want it in factor form. They want us to multiply this out. So it's going to be a lot of fun. All right. Since x equals negative 7i is a 0, we know because of the conjugate that x equals positive 7i, right? Because it's a plus bi is the format, so the conjugate is a minus bi. So if a is 0, right, we have negative 7i, then 0 plus 7i is going to be our other value. We also have that x is equal to 9/5. Right? Now, remember when we were solving zeros, this was like the final line. All we're going to do is we're pretty much finding our zeros, except we're going in reverse. Okay, so here we have 5x is equal to 9. So 5x minus 9 is a factor. Okay, here we're going to say, well, this is x minus 7i is a factor, and x plus 7i is a factor. Okay, so all of that just came back over. Okay, there is technically a spot in here with the, when we did the zero factor rule. So these were all equal to 0. Okay, but we're going to just jump from that to the factors. Right, and then I have to multiply all of this out. Okay, I would suggest dealing with the complex conjugates first, because the whole point of a conjugate is that those middle terms go away, and I'll show you. So if we have x plus 7i and x minus 7i, if I multiply this out, right, we get x squared, right? We get plus 7 and 7i x, that's my inner term. My outer term, right, is minus 7ix. And then my last are going to be minus 49i squared. This middle term stuff, this plus 7i minus 7i, this always goes away. So we have x squared. And then remember, I squared is really negative 1. So we have negative 49 times negative 1. So plus 49. So that's my term for these two. All right. Now, we also have to multiply out by 5x minus 9. This one isn't so bad. Right. So we're going to end up with 5x cubed. Right. We have a minus 9x squared. Okay, we have, what's 49 times 5? 145 or something? I don't know. 5 times 49. 245. See, I'm glad I checked. Okay, so that's plus 245x. Right, that was 5 times 49. And then the last one is 9 times 49. That's going to be a minus. We're going to have 9 times 40. What is that going to be? That's going to be 49. That's like 49 times 10 minus that. So that's going to be minus 441. No, how cute. Okay. So there's my answer for this. Let's see if it works. All right. So And notice, like, all of those steps, they all had to be good. So if you messed up your arithmetic on any of those, like, it ain't going to work. Oops. Speaking of messing up my arithmetic, 5x to the 3, glad I said we have a cubic, minus 9x squared plus 245x, excuse me, minus 441. All right. And let's check. All right. And it's happy, so we can move on. I'm going to make this a little bit smaller. I don't know how you guys do the laptops, I really don't. All right, now this one is polynomial with lowest degrees. We have -1, 2 with a multiplicity of 3, and f of 0 is equal to 16. All right, so let's go ahead and start with what we have, and then we'll talk about some other things. Okay, so we need an x equals 0, or x equals -1 rather, and this is happening one time. We have an x is equal to 2, and this is happening 3 times. But we also have an f of 0 is equal to 16. Okay, and if you remember back to the graph transformations, right? We, like x, we have a k out here, right? This would scale it. It would either stretch it or it would compress it. And that's what we're doing with this. We're saying how far up on the graph does this thing have to go? So when we're done, we're going to have a k or a c, or pick your favorite letter. Okay, I mean, don't pick x, but like pick a, pick k, pick c, pick some, a, b, c, k, and c. Those are letters that we usually associate with constants in math. Okay, x, y's, and z's, s's and t's, u's, v's. Those are all variables. But and m's and n's and things like that, those are those are counters. So you could use that, and that would be fine. All right. So here we have x plus 1, right? And this happened one time. We have x minus 2, and this happened 3 times. And I have some kind of a k at the front because we know that f of 0 is equal to 16. Okay. So that's what we have right now. And then let's figure out what's going to happen here. So we have k times 0 plus 1, right? Because we're plugging in 0 for the x's here, right? We have f of 0 equals, and then 0 minus 2 cubed, and this has to equal what? This has to equal 16. Okay, well, we have k times 1, and then -2 cubed, that's going to be -8. So we have -8k equals 16. Divide everybody by -8, divide by -8, and we get k is equal to -2. All right. So my function here, my thing that I'm going to be dealing with, f of x is equal to, we have a -2, we have x plus 1, and we have x minus 2 cubed. And if you think for one moment they're going to let us write that down and have a good day of it, you've got another thing coming. And what that is going to be multiplying it out. All right, so let me just show you, -2. All right, I'll take the hit on this one. Oops. See, they literally will not let me hit a parentheses. So they're telling me implicitly, well, they didn't say explicitly, they didn't say write it as a polynomial, multiply it out, but they took away the parentheses. I can't do that. So I've got to go through and multiply this thing out. Say thanks. Okay, so on one hand, it's pain. On the other hand, part of what we do in intermediate algebra is we practice multiplying this out. So at least they're hitting us like for 2 for 1, right? We don't have to do this multiple times. We don't have to go through a section where we just multiply out, right? That's minus 4x plus 4, right? So -2 minus 2. At the end, we have positive, and we still have an x minus 2 here. All right, we got to multiply all of that out. Now, there is a shortcut. All right, it's called Binomial Theorem. It will let you do this in one step. If you go look up Purple Math and then do a search in their little thing for binomial theorem, they have an excellent, really well scaled for our level little module to let you do this. Okay. They teach the binomial theorem, by the way, everywhere from about like algebra 2 in high school. I mean, we don't do that in Albuquerque, but there are other schools that do. It's fine. But binomial theorem goes everywhere from like algebra 2, maybe even lower. Okay, maybe some places do algebra 1 for this, all the way up to grad school. Okay, so if you clicked on a YouTube thing and they're going off about stuff and you're like, this is way over my head, like chances are it's meant for a higher level of math. So this is one of those things that scale from like grades 9 to, I don't know, what would be 16, 9 to 17. Okay, first year grad school being 17. So just realize that this is presented in a lot of different levels. Find one that speaks to you, and the purple math one is really good for this level. All right, multiply all of this out now. We've got x cubed, right, minus 2x squared, right, that's this one. And then we've got minus 4x squared, right, and plus, right, negative 4 times that is plus 8x. And then we have plus a 4x. And then last is minus 8. Add those together. So x cubed minus 6x squared plus 12x minus 8. All right, and that's this whole thing right now. Now, we're not done yet. We still have to do this one. All right, we still have x plus 1, and then we have to double everything and change the signs. All right, so we're not even close. Yeah, 2 times 3 is going to be 6, and 4 times 3 is going to be 12, and then, yeah, we're okay. Binomial theorem, just to make sure I did it right. So negative 2, and let's go ahead and multiply all of this out. So this is going to be x to the 4th, right? We're just adding up one more x here. Right, that's this part. Right, then underneath of it, we've got an x cubed minus 6x squared plus 12x, right? This was a minus, wasn't it? Here's and then minus 8. I like putting them on the different rows and lining up the different parts because I will, if I try to do this on one line and then hunt and peck for like what's going on, I'm going to lose them. So hopefully you had an algebra teacher that showed you this ages ago, but if not, I'm showing it to you now so that, hopefully it's a little bit easier to group these things up without spending all day looking for them. All right, this is a minus 8x plus 12, so it's going to be a positive 4x, and then just the minus 8. And then we get to double it, but change the sign. So negative 2x to the 4th plus 6x cubed minus 12x squared minus 8x plus 16. Right, that's what we're looking at. Let's see, did we get it right? Okay, because again, I get it. There's a lot of moving parts here, and you could have messed up anything along the way, and the computer is going to be upset with us. 6x cubed. Right? So I'm not promising perfection here. Okay. Minus 8x plus 16. All right. So fingers crossed. No. All right, let's see what we got here. I'm going to cheat here and just be very stubborn and see what my error was and have it tell me. Right there. See, there's some of the x, there's some kind of a 6 plus something. with my cubic term. Let's see. These are added, so that 2 and 4 really does make 6. Right here, something happened. This should have been minus, oh, right here. See, minus 6 plus 1 should have been a 5 here. All right, should have been a 5. When I multiply by that by -2, -5 really, that should have been my 10 right there. All right, so I feel for you. I understand, like, they took all the points, don't they? It's like, oh, you made a mistake, you're wrong. Okay, so but I get it. It's a lot to keep together. All right. All right, let's move on. Okay, write a polynomial. See, I didn't get it right either. Write a polynomial that satisfies the given conditions. Right. We're on number 7, right? Yes, we are. Okay, so write the polynomial with lowest degree with lowest possible integer coefficients with zeros of 3 minus 6i and 0 with a multiplicity of 5. All right, that looks delightful. So let's go through and do that one. Okay, so again, so we have x equals 3 minus 6i. We also have x equals 0, and that happened 5 times. But because 3 minus 6i is a 0, I know that 3 plus 6i is a 0. Right? Be careful with your signs on this one, because a lot of people, they'll make both of these things. So let's see here. If I push it back to linear terms, we have x minus, right, 3 minus 6i. And in here we have x minus 3 plus 6i. So all I'm doing is swinging this over, right? If this was 7, we'd say x minus 7. So try to group this in one thing, and that might help a little bit. And in here we have x equals 0. It happened 5 times, so we have times x to the 5th. All right. And again, if you think that there's going to be parentheses here and they're going to let me get away with writing this down, no. They're going to force us to go through all of this stuff again. All right. The easiest thing to do is to deal with the conjugates first. Okay. So let's go ahead and multiply that out. All right. You could factor the distribute. You could factor the or distribute the negative sign first. That's fine. I'm not going to do it this time. I'm going to say this is x squared. Okay. And then we have a minus 3 plus 6i x. And then we have a minus, right, that's this one, 3 minus 6i, 3 minus 6i, x. These don't cancel yet, all right? This part will, but the other parts won't. And then we have minus times a minus, so we have a plus. And then we have 3 minus 6i and 3 plus 6i at the end here. Okay, that's this times this one. That's our lasts. All right, and just to make sure that is a plus. All right, now we have some distributing to do. So we have some x squareds. We have a minus 3x minus 6ix minus another 3x. Minus times a minus is a plus 6ix. Plus, and I'm just going to leave this in the middle here for a moment. We have 3 times 3, that's 9. We have a minus 18i, that's my inner part. We have a plus 18i, that's my outer part. And then we have a minus 36, right? 6 times 6, 36i squared. Right? So let's start combining some terms, right? You see that we have a negative 6i and a positive 6i here, right? So we have this one and this one. Those are going to cancel. This one and this one are going to cancel. Right. So here we have x squared. We have minus 3 minus 2. That's minus 6i, or minus 6x rather. No i's. Plus these canceled. So we have, this is a 9 minus 36i squared. I squared is really -1. So we have 36 plus 9. I believe that's 45. Right? So let me just show you something to see whether or not you got this right. All right, that might help a little bit. If I had to break this back down into zeros, right, I can't factor this. So we need some way of being able to solve a quadratic, some kind of a formula that would help us solve a quadratic. Oh, that's right. We have 6, right? We have -b plus or minus the square root of b squared minus 4ac, right? All over 2a. So we have -6 plus or minus. We have -6 squared here minus 4 1 times 45 all over 2. So this is x is equal to 6 plus or minus. We have 36 minus 45 times 2 is 90. 90 and 90 would be 180 all over 2. X is equal to 6 plus or minus, what is 36 minus 180? Oh, look at that, 144. And I know the square root of 144, right? That's 12. So this is 6 plus or minus 12i all over 2. If I divide both of these terms by 2, right, this is really 2 times 3 plus or minus. Take a 2 out, that's 6i over 2. And what were the two zeros that I was told about? 3 plus 6i and 3 minus 6i. So I'm pretty happy that, I'm not going to promise the rest of the problem is going to be right, but at least up until here, we're good, right? Actually, the rest of it's not so bad because we just have to multiply by x to the 5th. Okay, so we have x to the 5th times x squared minus 6x plus 45. I think I can handle this one. All right, that's x to the 7th minus 6x to the 6th plus 45x to the 5th, and there we go. Let's see if the computer is going to be my friend. Or am I going to be flawed again here? All right. Yeah, we'll put it up here. We'll make it a little bit smaller. Again, I don't know how you guys do this. All right. X to the 7th, right? Minus 6x to the 6th plus 45x to the 5th. I think we're good. Yeah, it didn't tell us we had to match anything at 0. Thank goodness, because I don't think we could. But all right, it's happy. So that should conclude 2.4 for us as a walkthrough. Like I said, if you need more of these to look at them, say, could you do like 3 of number 6 and get them right this time? Like, you can email me this, and I'll provide more of them. Okay, so that's what we have. All right, good luck doing this. It's a lot to keep track of, I know, but try your best with it. I'll say it with me. I did the last time. It builds character. All right. So take care and do your homework.